Hello, my name is Adam McMahon, and I am an undergraduate student in biological and pharmaceutical chemistry. Over the summer, I have had the privilege of working in the Auzanneau lab in the Department of Chemistry, studying carbohydrates. Many tumors overproduce a variety of carbohydrates, which are of great interest to cancer researchers. These molecules are referred to as Tumour-Associated carbohydrate antigens, or TACAs. My summer project focused on the synthesis of Lewis Y, one such TACA that has been found on many types of cancer, including breast, lung, and colon. This compound was synthesized from the sugars galactose, N-acetylglucosamine, 2 fucoses, and a nonyl bromide chain. Linking 2 sugars through a glycosylation reaction is a complex task. One sugar needs to have a leaving group on the first carbon, and the other needs to have a free OH group. The leaving group falls off the sugar, forming a positively charged oxocarbenium ion. Then, the free OH on the other sugar links to the positive center, forming a bond and releasing an H+. Any free OH group could react in a glycosylation. Therefore, OHs need to be blocked and unblocked selectively. This is called protection and deprotection, respectively, and there are many strategies to do so, several of which were used in my project. Isopropyridine protection is a method used to protect 2 OH groups that are adjacent and on the same side of the ring. If the OH groups are on opposite sides of the ring, with one facing up and the other facing down, the isopropyridine will not add. To add an isopropyridine, acetone reacts with the sugar in the presence of an acid. Concentrated acid can later be used to remove the isopropyridine groups. In molecules with multiple isopropyridines, using less concentrated acid can selectively remove the C1-C2 isopropyridine, in purple, while leaving the other one on the molecule. Pivyloyl protection can be used to protect the 6' OH without touching the other OH groups. To do so, the sugar is carefully reacted with pivyloyl chloride in dry conditions. Sodium methoxide in methanol can quickly remove pivyloyl groups. Acetyl groups can be added to every free OH using acetic anhydride and pyridine. Using a suitable catalyst, the acetate on the first carbon, shown in green, can be removed and replaced with a better leaving group. Other similar molecules, such as benzoyl chloride or chloroacetyl chloride, can be used in a similar fashion to produce slightly different sugars. Similar to pivyloyl groups, acetyl groups can be cleaved with sodium methoxide in methanol. Alternatively, magnesium methoxide in methanol can be used to keep pivyloyl groups on the molecule while removing the acetyl groups. My project began with a start material made by Desmond Gilmore, although more was later synthesized. The first step was trying to use magnesium methoxide to remove the acetyl and chloroacetyl groups, shown in green, without removing the similar benzoyl groups in red. However, this did not work, even after trying different concentrations of magnesium methoxide and different solvents. Instead, all 4 of the acetyl-like groups were removed with magnesium methoxide, and the O3 and O4 were protected with an isopropyridine. This sugar was eventually linked to 2 fucoses. To prepare the fucoses, the OHs were acetylated, and then the C1 acetyl group was replaced with a sulfur-based leaving group. The acetyl groups were subsequently cleaved with sodium methoxide and methanol, and replaced with benzyl protecting groups. Finally, the sugars were linked in a days-long glycosylation reaction. This reaction required several catalysts and had to be kept extremely dry. In the future, the protecting groups will be removed, and the bromide will be replaced with the ONH2 group. The sugar will then be linked to a long polysaccharide and tested for immunogenicity. Thank you for listening to my presentation. I would like to thank the members of the Auzanneau group for their help, specifically Dr. France-Isabelle Auzanneau and Charles Gauthier, and to the NSERC USRA program for funding.